A baseball is thrown at an angle 25 degrees relative to the ground at a speed of 23 meters per second. If the ball is caught 42 meters from the thrower, how long was the ball in the air? How high above the thrower did the ball travel?
Okay, so the information that we have is that the angle is 25 degrees. Delta x is 42 meters. The initial velocity is 23 meters per second. So now, the first thing that we have to do is solve for time, the change in time.
So in order to, the first equation that we use is a kinematic one that is in our book on page 98. And I use this equation because it allows me to, it's really just the rearranging of motion along the x-axis to isolate change in time, the unknown, which is what we're looking for. And after we solve this equation, we'll find the answer to t. So first you write down delta x equals initial velocity cosine the angle times delta t. And so once you plug that in, all your numbers, you honestly just solve it out. You divide, first you could solve 23 meters per second cosine 25, whereas here we did that, and then we ended up just dividing everything by 20.845, and your answer is delta t equals about 20 seconds.
Now that we know time, we can answer the question, how high above the thrower did the ball travel? So in order to find this, we use the equation delta y is equal to vy over delta t. But in order to find vy, we use the equation vy is equal to vi sine angle measure.
All right, so now we're looking for Vy. So we just use the equation Vy equals initial velocity times the sine of the angle. Then we plug in the initial velocity and the angle. We solve it, and then Vy equals 9.75 meters per second.
So now that we have Vy, we can find delta y, or how high above the thrower did the ball travel. So the equation we use is delta y equals Vy over delta t. So we plug in the numbers, 9.7 meters per second over 2.01 seconds, and delta y turns out to be 4.83 meters, which answers the question, how high above the thrower did the ball travel?